Alrighty, good evening, everyone. This is meteorologist Timmy Albertson here with you guys for tonight's weather chat. Hope you all had a pretty good Thanksgiving out there. I know that it was a little bit mild for some places, but then we had ourselves a kind of nice cold front sweep its way across a good part of the Midwest, and that has since dropped those temperatures down into the teens. Now, with that lower temperature has come the production of some lake effect snow showers. We'll take a little bit of some lake effect snow happening in various parts of the Great Lakes. And for those of you like me who grew up around the Great Lakes, lake effect snow is a rather common occurrence, especially this time of the year. So, what makes lake effect snow? Well, kind of the biggest thing that kind of produces lake effect snow is you need yourself a pretty good temperature contrast in the lower levels. And typically, the rule of thumb that we use in meteorology is any temperature gradient or any temperature contrast that is greater than or equal to 13 degrees Celsius between the lake temperature and a couple thousand feet up above the atmosphere, or not above the atmosphere, above the ground, is kind of the standard there. That provides enough instability. And long story short, we'll kind of take a little bit more of a look at that. But we do have conditions being met all across parts of the Great Lakes that have been leading to some decent lake effect snow bands. So, without any further ado, folks, let's go ahead and take a look on over at the Upper Peninsula here of Michigan, and we're going to take a look here at some lake effect snow that is going on there. Now, on the radar imagery, this might just look like some light precipitation, but this is falling as snow. Temperatures around this area are in the upper, mid to upper teens right now, so it is certainly some snow there, and of course, that's probably leading to a good ice to liquid ratio, which does vary based on the temperature. And when we're dealing with temperatures in the teens, that's a kind of means a little less moisture. That it means the less moisture that you have still produces a good amount of snow there. So, all right, let's go ahead, folks, and take a little bit of a look here at the radar imagery. So we're looking just to the west here of Marquette, or just to the east here of Marquette, Michigan. And we can kind of see we got these little bands here, more or less, of this precipitation here. You can kind of see one band right here, another band here, and kind of this band making its way just to the east there of Marquette. Now, if we were to go ahead and loop this just a little bit, you can kind of see how these guys are traveling here. And basically what happens, for those of you who are not familiar with lake effect snow, is as long as the wind direction doesn't really change much, these bands don't really shift much, if that makes any sense, which means, well, if you're caught underneath one of these heavy lake effect snow bands, it could be near blizzard like conditions for quite a while. But if you go a few miles in either direction, it could be a lot quieter, maybe not even seeing much in the way of snowfall at all. And that looks to be the case right here. What town is this here? This is, I believe, Mountain. If I'm pronouncing that right. Over here, let's go ahead and kind of take a look at their surface observation here really quickly. Again, it's 19 degrees there, dew point about 15 degrees, winds coming in from the west about 13 miles an hour. So that's a pretty good steady breeze there coming off. We could just see here, if we look at this radar image, how this one particular band has just been kind of sitting right on top of that area, not really moving much here. Now, again, what we're kind of seeing here are more or less kind of some lake effect snow bands here. So basically, what's going on here is the temperature of Lake Superior. Yes, it is cold, as it normally is throughout the year. However, the surface temperature, the air temperature that's making its way off land going over the lake, is significantly colder. It's in the teens. Now, we obviously can't have water temperatures in the teens, because then at that point it would be ice. But moving rapidly along here, this is a pretty good temperature contrast that we're seeing. We'll take a look at some of the maps here in just a little bit. Basically, what we're seeing here is a little bit of convection, you could say here. We got ourselves that warmer lake water that is sitting right underneath of some much colder air temperature that's making its way off the land here. And so that produces the instability, much like what we kind of expect with a thunderstorm, only in this case, temperature contrast isn't necessarily all the way up across the atmosphere, but it's just enough here at the lower levels that it does kind of produce these convective bands, and the winds then push them onshore. And that's what we see here. That's lake effect snow. And as mentioned, that kind of happens across much of the Great Lakes, predominantly on the eastern edge of the Great Lakes is Lake Erie in particular doesn't necessarily see northeasterly winds all that often. So again, places like Toledo, not really lake effect city. Places like Cleveland, the east side, yes, and Erie, Buffalo, those are all lake effect snow locations here. So that's just one area of lake effect snow going on. Let's go ahead and flip down over here to our friends up in the Traverse City area, take a look at that. Much heavier snow bands ongoing there. If we're going to loop this here, we get kind of the same picture. Again, we're going to take a look at the charts here in just a moment here, but let's just take a look at the radar. You can see particularly a little heavier band of snow making its way there to around the, let's see that, Monsalina area. Kaleska, I can't pronounce all the town names in the world, but there you go. Kind of just tracking its way, certainly some heavy snow. Looks like it's dropping its way further down to the south here, but overall, you get the idea. Is that the only area of activity we're seeing? No, not at all. Let's go ahead and take a look over in Ontario. They got a nice little lake effect snow band here north of, let's see here. Well, Sarnia is going to be down around this area here. Oh, there's Sarnia. So uh, kind of out there in the Kincardine area of Ontario. You see that there's a nice little lake effect snowband right there. And sometimes what we get, if conditions are just right, is we get these, individual snow bands to kind of become rather intense. And as a matter of fact, that is something very common, or not common, I should say, but something that we see in Lake Erie that actually really plays an important part here. Let's take a look at Lake Erie here, and you can see their lake effect snow event is a little bit different around the Buffalo area. Let's go ahead and loop this, and basically what we see is one particular band here that's very heavy. Now, what's happening down around this area is, believe it or not, the winds are coming in from the southwest, and they are carrying themselves over the length here of the lake. And that plays a very important role when it comes to lake effect snow, is how much time is that air spending over the waters. If it's you know, basically passing over a small part of the lake, we don't necessarily see quite as much lake effect snow. This whole thing is called the fetch, but with a southwesterly wind, you can see how that would spend a good amount of time over Lake Erie, because Lake Erie is somewhat tilted from the southwest to the northeast. So that air has a long time to sit over the lake. Then it has been warmer out in that area. So certainly a decent temperature contrast. And in Lake Erie's case, is that sometimes produces a very single band of intense snowfall south of the Buffalo area. For those of you who might know your weather history, back in 2015, in November, they had a really good lake effect snow band that produced about 7 feet of snow in what was about 36 hours or so. So these bands can be very heavy. And again, with the orientation of Lake Erie, sometimes it does set up to have these really decent snow bands here. Special weather statement, as a matter of fact, over from the National Weather Service office in Buffalo. Let's just kind of take a quick peek at what they're saying with it. And let's see here. Visibility is less than a quarter of a mile. Yep, and that's likely going to be hanging around there for at least a little bit here. Again, that wind not really changing its direction much. Folks, that is a really good snowband, by the way. If you've ever driven in a lake effect snowband, like I said, it's kind of like a little miniature blizzard. In the case of this thing, it's a little bit more than a miniature blizzard, but it is, again, kind of localized. You can see, again, this is the Buffalo, this is the city of Buffalo. They're not really seeing much of anything, but yet they're getting hit hard in the south suburbs, West Seneca, more so the Hamburg area. And again, if you were to kind of go further down to the south, though, not really much. So again, these are very localized here. A lot of times when you see it on the news and they say, oh, Buffalo slammed by a massive winter storm, this is probably what they meant. And again, it's not the whole state of New York. Again, these are lake effect snow bands are somewhat localized, and that does make things very interesting, especially in terms of forecasting. Again, in one metro, you can see the north side not really seeing much activity at all, and the south side getting hit with lake effect snow. And again, folks, that happens all across the Great Lakes area, depending upon where you are and the wind direction. So let's go ahead, everyone, and take a look at the latest weather map here. All right, let's take a look here. There's our system that passed its way through a couple of days ago, swirling its way off the Atlantic coast. We have this very steady northwesterly breeze that is pushing its way in across the western half of the Great Lakes. Because the way the air flows around a low pressure, it is counterclockwise. And all things considered, if we go down a little bit further to the south, we can see that kind of at the edge of that low pressure, those winds are a little bit more southwesterly. Again, just kind of standard with that airflow around a low pressure. And again, that is what is helping to produce that very heavy snow band over around the Buffalo area. Whereas up across Marquette, the winds are coming straight out of the northwest, and that's kind of helping to produce that lake effect snow over there. So if we were to kind of zoom out a little bit on the radar, you could see that these lake effect snow bands not necessarily all angled in one direction. They're kind of mimicking the wind flow with that area of low pressure. Is this going to continue? Yes, it's going to be continuing as we head through the overnight hours, but then we'll start to see this whole mechanism begin to kind of break down a little bit, as we could very well be seeing another system getting ready to move in that could warm things up a little bit. But at least for the overnight tonight, that lake effect snow is likely going to be continuing. Let's take a look here at some upper level maps here. Again, there's our upper level trough there, really just kind of pushing its way through. Very well defined here, but let's go ahead and take a little bit of a look, folks, over at the Great Lakes region, and we'll take a look at some of the values here. So, as I mentioned, with our lake effect snow, we like to see a very good temperature contrast, and there is a pretty good temperature contrast for you there. Temperature is easily about 20 degrees Celsius or more of a difference between the surface of the lake and about 3,500 feet or so above the ground. So that's a very sharp temperature contrast. Again, that air mass that's making its way off land is going over these water temperatures, which are still relatively warmer, and that is enough that it is really kind of, again, like I mentioned, it's enough to produce a little bit of a locally unstable weather environment, and that is what we are seeing. Take a look here. If we were to go ahead and flip on up to the radar here, we'll go ahead and want to flip on the radar here so you guys can again see kind of what we're talking about with that lake effect snow. Again, a little hard to see here on this particular radar, but we took a look. Again, there's those heavier snow bands up and around Marquette, and then there's some more coming off the West Michigan coast. Again, you can see these ones angled a little bit from the northwest. These ones more westerly, and down here a bit more southwesterly. This one around Buffalo showing up a lot better on this particular radar image, just because it is a lot heavier. So if we were to go ahead then and also kind of take a little bit of a look at some of the other conditions around here, boy, look at that wind shear. It is uh, not really that big. And we talk about wind shear a lot. Again, it's the change of wind direction or speed with height. And in this case, when it comes to lake effect snow, you don't really want a lot of wind shear. You can have some, but you don't want a lot. And the reason why you don't want a lot of wind shear mainly goes because it'll really rip apart the lake effect snow band. Again, they're kind of interesting in that regard. When we talk about severe thunderstorms, we like to have wind shear, but in terms of lake effect snow, we do not like to have wind shear because that really messes it up a little bit. Again, you can have a little bit of wind shear, but if you have too much wind shear, again, it's kind of the about 30 degrees or less will 30-degree less directional wind shear will you know, favors better snowfall bands, about 60 to 30 degrees, and it gets a little bit dicey. And once you get more than a 60-degree, wind shear, you're probably not really going to be seeing much of anything at all here. So again, wind shear values across the Great Lakes, at least in, the kind of the lower levels, very minimal right now. In fact, over Lake Erie, they almost appear to be pretty much right on it, pretty much even. And that's part of the reason why they're seeing such that decent lake effect snow band. Now, if we were to look over towards Lake Superior a little bit, there is a little bit more wind shear, especially right up across the Upper Peninsula. Not a lot, as we still have that lake effect snow going on pretty well there, but there is a little bit more at least than there is over Lake Erie, and so that's probably part of the reason why their lake effect snow band maybe not quite as heavy, but still certainly seeing quite a bit of it. And again, this is kind of the area of the lake effect snow across the Great Lakes. So nothing unusual for this time of the year. A little bit overdue. We haven't really had much in the way of lake effect snow events so far this month. Sometimes, normally we see them a little bit earlier, but hey, better late than never, that's for sure. So again, really, again, a very good atmosphere. I mean, look at these temperatures, only a couple thousand feet above the ground. We're talking about 16 degrees below 0 centigrade, which, if we convert that into Fahrenheit, is getting close to about 0 degrees. So we got temperatures down across near Lake Erie, they're in the 30s, and then we have temperatures, not too high, not that much higher up, that are easily 30 degrees colder. So again, very unstable there. Very, very, temperaturely, I guess we could say that we're temperaturally unstable. Whatever, we get the idea. So that's a little bit of a look at what's going on right now in the Great Lakes, as is normally the case this time of the year. That's a really good lake effect snow band down across this part of I-90. I've driven so many times, and like I said, Wouldn't be surprised given that they may shut it down for a little bit. Not unusual, especially when you have a lake effect snow band like this. So these guys, like I said, can produce quite a bit of snow. It looks like right now a lot of the estimates could be near about a foot of snow in some of these locations. It has been ongoing throughout the day, especially up across the Upper Peninsula. They've already seen quite a bit of snowfall. So tomorrow, my guess is that we're going to have a lot of snowfall totals to take a look at, and we'll see exactly how they line up, and that'll really kind of help to visualize the areas that we tend to see lake effect snow in most often. Now, I say most often, there are some exceptions, and again, it really depends upon the wind direction. But some places don't really see lake effect snow very often, and if they do, it's actually probably more rare. Detroit, even though it sits right up on the lakes, doesn't really see it. Toledo, Ohio is another place that doesn't really see much in the way of lake effect snow. Once you go north of Buffalo, not very common either. So really, it's because you're up on the Great Lakes doesn't mean you see lake effect snow. Things get a little trippy though up here in this part of Michigan, because if it's strong enough, sometimes these lake effect snow bands, even though they're not normally as strong as what we could see off of Lake Erie or Lake Superior, because again the wind predominantly blows over less water area. But sometimes in certain conditions we could get lake effect. When we get lake effect snow, which does happen across the western part here of Michigan, if it's strong enough, it can sometimes carry over into the center part of the state. But typically by that point, it's mainly just flurry. So places like Alpena, Bay City don't normally see a lot of lake effect snow. Again, predominant wind direction is westerly. So if it's sitting on the western edge of the lake, now there you go. Not really much moisture for it to work with further down or further upstream. So again, those are some areas. Chicago doesn't really get lake effect snow that often. If it's a straight north wind and condition temperature wise are good, and same thing with wind shear, they can get pounded pretty good in Gary, Indiana, with lake effect snow, but that's not very common throughout the winter. Maybe about once a year or a couple times, but typically once you get up to about Michigan City and then heading north, that's kind of a little bit more of the lake effect snow alley. But like I said, there have been instances I have seen before where Gary, Indiana, Hammond can get really, can get hit pretty good with some lake effect snow. But again, it's not very often that does happen. Again, Chicago, Milwaukee don't really get lake effect snow. Again, they're on the western edge. So a lot of times when you look at a map of the Great Lakes, it's the eastern edge of the Great Lakes that will see that. For the case of the Upper Peninsula, there you go. And it has the courtesy of Lake Superior, which doesn't really freeze over in the wintertime. So that can continue throughout the winter. But Lake Erie, sometimes if it's cold enough, will freeze over. A little bit, and that will actually affect lake effect by shutting it off because there's not really much moisture for it to work with. So that is part of the reason why sometimes the lake effect snow totals down across the eastern parts of Lake Erie tend to be a little bit lower, even in the coldest winters, because that lake could freeze over just a little bit, just enough that it would throw everything off. But Lake Superior doesn't really freeze over very much. And let's take a look at them. Again, their winds are kind of, again, a little bit here, almost straight westerly. And again, there does appear to be a pretty good band there, albeit a little disorganized. Well, not disorganized, but appears to be about right there. Let's go ahead and loop this here a little bit and see exactly how this little dude is moving. So again, these lake effect snow bands, and what's really fun is forecasting these things. We know it could happen. Well, a lot of times when we do forecasting, we know lake effect snow is going to happen, but it's very difficult. Now, sometimes in this type of a setup, like what they're seeing in Buffalo, yeah, that sometimes is kind of a given. And again, historically, this is the area that they would affect the most, this part right here of New York. So again, southern part of Buffalo Metro heading down towards about Dunkirk. But otherwise, when it comes to forecasting lake effect snow, can sometimes get a little bit tricky, as a lot of it depends upon those snow bands and where they set up. So a lot of times, if you go down around that area, if you're not familiar with it, it's not unusual to see a forecast of, 6 to 12 inches, possibly up to 2 feet. That might sound like a heck of a range, but uh, sometimes that is actually how it works. And again, it can be very localized. That could be seeing some of those high snowfall totals. So again, like that 7 feet of snow that happened back in 2015, the north part of Buffalo itself only got 6 inches of snow. So that was a heck of a variation. And actually, I remember about a couple years after that, they had a very similar lake effect snow band But instead of going into Buffalo, it did actually kind of drift a bit to the south and it hit Erie, Pennsylvania, which, if you've never been around the Erie area, is kind of interesting because typically when they get lake effect snow, it's from a northwesterly wind that blows across the lake. In this case, it was a southwesterly wind, but the snow band had drifted just enough south that it hit downtown Erie head on. Typically, in lake effect snow events, especially in this part of Pennsylvania, the higher snowfall amounts will happen back over in this part of Erie County, a little bit further from the lake. Part of that has to do with the topography. But in this case, yeah, they got about 6, 7 feet of snow also in about 36 hours right across downtown, which was a little unusual, just given that historically the lake effect snow events that happen almost every day during the wintertime. But typically, they're angled from the northwest, so they're not as heavy snowfall bands. They are still decent. Uh, and typically, there's a little bit of orthographic lift that kind of plays in a part of that. So, lake effect snow, not unusual in that area, but certainly getting that 7 feet of snow right up here on the lakefront in that part was unusual for the most part, just given the intensity of it. Now, again, not unusual to see these lake effect snow bands producing that type of snowfall. Typically 7 feet's normally on the higher end, but a couple feet certainly very likely, or often occurrence or an often occurrence. But again, with Erie's, it was just a little bit interesting because they typically don't see that much from one lake effect snow event just because of the predominant wind. So it can happen though if you're in the lake. If you go to around the Cleveland area, Ashtabula, Menor, Euclid, get lake effect snow, albeit not quite to the extreme that they'll get up around Erie and Buffalo. But if you go to the west suburbs, they don't really get much. They'll sometimes get some flurries around Lakewood and maybe Westlake, but that's about it. So again, part of the reason for that is the way Lake Erie is kind of west to east here, and then it turns up to the north here. So if you go to Cleveland, it's the east suburbs that get the lake effect snow, much like how in Buffalo it's the south suburbs. So again, within one metro, you can have a heck of a difference. Again, Toledo doesn't really get much of it. Neither does the Windsor area. London, Ontario, under right circumstances, can sometimes get in on a little bit of the action off of Lake Huron, but typically that's normally not quite as extreme as what you could be seeing if you were closer up around that area. Watertown's another lake effect snow. Toronto, not really. Toronto again. If there's a strong enough moisture connection, it can sometimes pull out some flurries, sometimes from Lake Huron, but that's really pushing it. So again, Toronto not really a lake effect snow city either. All righty, everyone. I think we've gone over it enough for tonight. There you go, lake effect snow happening. So with that in mind, we will take a look at snowfall totals and everything else during tomorrow chat, which we will do again this time tomorrow evening. In the meantime, I thank you all very much for taking the time to join me here, listening to my excited rants about lake effect snow. I absolutely love it. It is great. And with that in mind, everyone, I hope you all have a good rest of your evening. We'll see you back here tomorrow evening for the next weather chat.